Alrighty, so now we're going to talk about the user experience around using Google Glass. So first of all, just to get some context, this is what Larry Page and Sergey Brin said about the technology. They said that Google should do the hard work and you should have a chance to live, have a good life and get on with it. So the computer should just be more comfortable. So the idea is the computer should just get out of the way and let you get on with your life. And one of the underlying goals is for the technology, as it becomes more personal and immediate, it should be able to start to disappear. So today people kind of feel overwhelmed by technology, but if we can get the technology out of the way, then it should be able to start to disappear a little bit. So let me talk about the Glass user interface. So I've shown you a little bit about how the hardware evolved over time, and now I was going to show you a little bit about the software interface. So when they first started thinking about Google Glass, they started looking at typical Android style interface. So you can see here, this is the initial first versions, and so what do you think might be a bad idea for putting this one on the wearable display? Why do you think this might be a bad way? Too big? Yep. Yeah, there's a lot of information, isn't there? So in this one, for example, you see here, there's probably 30 or so icons. So lots of stuff appearing on your display. So it's quite distracting. So over time, the user interface evolved. So they started off by having many icons, and then they had kind of a strip of applications that you could look through here, and then they did some type of augmented reality trials where they could put tags appearing on the real world. Then some of you may have seen the early video that they made with this kind of bubble interface as well. And then they finally decided to simplify it down and make this kind of card metaphor. So you can see these cards here. And this is where we got to today, where instead of having many icons on each page, like here, you can see now they just have one card for each piece of information. So the basic user interface is that you have the metaphor is that you have a strip of cards that appear in front of your eye, and as you touch or swipe with your touch bar, the cards will change. So let me show you a little live demonstration, and then I'll tell you a bit more, then you can try it for yourself as well. So it's a little bit difficult to demonstrate Google Glass because the screen is in here and people cannot see what you're seeing. So what we do is we have to plug it onto here, and then when you plug it, you can then run another application that will I'll let you see what's on the screen here. So let me just go here, and there's an application called something called Droid at Screen. Run this application, then okay, now it's running. So this is what I'm seeing on my display right now, and this Droid at Screen application is going to be very useful. So later on, when you start doing your own development, you should download a version for yourself, and this means that you can now see what's on your screen without having to look at the display or show somebody else as well. So this is so right now the screen is off. If I touch it with the side of my finger, it turns on. If I swipe horizontally, you can see different pieces of information appearing. So as you can see, there's one piece of information per slide, and if you look at the bottom, you can see the time as well. So this was information from 2 days ago, and then if I go back towards the clock, this is yesterday, and then this one is a picture that was taken 2 hours ago. It's kind of a blurry picture, and then some other things that started up. So this is the home time here, and then as you go further away from the clock, the slides go back in time. So this is 2 days, now 3 days ago, and so forth. And then if you go that's to the right of the clock, and if you go to the left of the clock, then you can see this is events today. There's nothing on my calendar for today. There's charging the battery as well. So this is things happening in the future. So the basic way to interact with the glass is by swiping. Yeah, you can swipe, you can flick, and it'll flick. Swiping here. You can also, and a second way is by flicking down. So if you flick down like this, it turns off, and by tapping. So swiping, flicking, and tapping are the three ways to interact. Then you can also use your speech commands. So when you have it on the clock like this, then you can use the trigger word there. So I can say, "Okay, glass." I can say, "Take a picture." And now it's taking a picture of everybody, so you can see there. So this is the hands-free interaction. You can also, there's a button on the top here. If I push the button here, and if I hold it down for about half a second, it's going to start recording a video. So now it's recording a video. It's recording just 10 seconds of video. And so now it's finished recording. And then I can swipe down again, it goes dark. Now if I swipe sideways, you see the video I recorded appears to the immediate right, and then there's the picture I took then, and then the other things as well. So you can see that cards are very easy to swipe between. With this menu here, or the clock, all of the things shown on the timeline is content. So these are all things like content from CNN or other things like this one. But there are also applications as well. And to access the applications, when you're on the home screen here, you can tap once, and it puts up a list of applications. So here is a list of different applications. So, for example, one application is a game here, so I can go along here. I can tap again to play game, and it puts up several game options. So tennis, shape splitter, balance, clay shooter, matcher, Spellista. So there are several games. Yeah, and I can swipe down, it goes back up again, back to the clock here as well. You can do other things as well. So I can go, "Okay, glass, Google, who is Barack Obama?" So now I send us a question out. It's going to tell me who Barack Obama is, and there it is. And it tells me when he's born and who's married to, things as well. So there's all the information about the president that you can pick up from Google.
Can you just swap back and forth?
Not around a circle, just in a linear, and yeah. So it's not. If I keep on swiping, it won't go back to the beginning. It just goes in a straight line. Yeah. So it gives you an example of using speech. You can also you can get directions. So, "Okay, glass, get directions to." Oh, that's right. I don't have my GPS tuner up right now. But anyway, so it didn't work out. So this is how you interact. So I'll pass around, and you can try for yourself. And then while you're trying, I'll talk a little bit more about the user interface and some design metaphors. So when you try this, you'll see that you might need to adjust the display to see. So when you wear it, you should be able to look up and see the display. If you can't, you might need to bend. You can bend this back and forward like this one here. So pass it around. You can try for yourself. And while you're doing that, I will talk a bit more about the So you see the user interface, as I showed before, is just a set of cards, and each card pretty much has one piece of information on it. And then they can store up to about 2 weeks information.
2 weeks.
Yeah, so it could be hundreds of cards, but obviously going through hundreds of cards like this is not a very good way to navigate through. So, yeah. So you have this timeline metaphor where what's happened. So this is the clock, which is the present time, and then what's happening in the past is on the right hand side. What's happening in the future is on the left hand side. So if I get directions, or if I check the weather, or other things, it all happens in the future. So as you can see, and there are a number of ways you interact with the display. I did not show you, but if a display goes off, you can tilt your head back, and it will turn back on again. So just if you want to try that, I'll just swipe down now. Now tilt your head up a bit further, about 30 degrees. There you go. Now it's turned on. So if you're riding your bicycle and you wanted to take a picture with Google Glass, but the display was not on, then you just have to tilt your head back up and turn it back on. The display will turn on, and then you can say, "Okay, Glass, take a picture," and it'll take a picture with the display. If you don't want to take your hands off the handlebars. So you can see it's really a truly wearable computer, less than 46 ounces. It has a number of hands-free information access, so there's voice interaction, there's a Ego Vision camera. When you wear it, you should try and hear the video as well. So if you swipe back on the timeline, you will get to the video recorder, then you tap on it, you can play, and you'll be able to hear the video playing through the headphones. So just, yeah, there we go, you can swipe along. So it has a quite intuitive user interface with touch, gesture, speech, and head motion, and it provides access to all the Google services, so searching, mapping, and so forth.
So now you had asked a question with Barack Obama,
Yeah.
and then the class find the answer automatically, or?
Yes, it goes to Google and answers automatically through Google, yeah. Using the Wi-Fi, that's right, yeah. Or if you had it, if you have with your mobile phone, you can pair with your phone and use the 3G on the phone, yeah. If you get lost, it looks like you're stuck there, Wei Ping, just flick down and or tap and it'll turn back to the clock, and then you can swipe along, yeah, and you can see along there. You should try playing the video because then you can hear the audio playing on your head as well.
There's some extra module for GPS or like
there's GPS on there, but normally I think the GPS hardware is actually disabled right now. So normally what people do is they pair to their phone, and then on their mobile phone you can get the GPS from there as well. So when you have the phone in your pocket, you can use one. This also works as a Bluetooth headset. So if you have a mobile phone paired, when you get a phone call, you will hear it on the glass and you can answer the phone. Yeah. No. So you can, but it has the Bluetooth, so you can pair to your mobile phone. I think they made that choice because they did not want to be perceived as a threat to other phone manufacturers. Also, it probably adds more to the cost as well. And plus, most people already have cell phone, so if they can just pair it to the phone, they get it there as well. So that shows you some of the user experience. Let me talk about some applications. So first of all, why do you think you'd want to wear a display like this? Well, one reason is because of a change in how you interact with information. So typically people will use cell phones all the time, and when they use the cell phone, they are looking down, like what Tom Chi was saying in the video before. They look down and they look at the phone screen or the tablet. So you're kind of living life heads down. But with Google Glass, you can always look up and you can see the content always and while you're looking at the objects in the real world. So they say it's the difference between living life heads up versus heads down. And it turns out people use their cell phones a lot. Somebody made a slide saying that there's at least 150 times a day people will use their phones, using voice call or checking the time messaging or something like this one. So if you add up all the time on your phone, you maybe an hour a day or so is looking at your phone screen. But in this case, we want to look not at the phone screen, but look in the real world. Now, Google Glass is an Android device, but currently there's no applications on the Play Store for it. But what you can do is you can get applications through a special website called the Glassware website. So if we go to this website here, I'll show you there's a list of different applications, and you can install them on your own device as well. So if I exit from this one, if I go to my email, and then from my email, oh sorry, not my email, if I go to www, oops, google.com/myglass. Then this uses my Gmail account and opens up my information about my Google Glass. And if I go to the glassware site here, then this has a list of all the applications that you have. So so here's some featured ones, and down here is all different applications. So Evernote, Facebook, Foursquare, Google Calendar, some kitchen applications, a whole range of Strava for bicycling, and so forth. There's a whole range of applications down here. So one application that I'd quite like to use is this one, Duolingo. It's not installed on my glass right now, so I'll show you how it sets it up. So you basically, if you want to use an application, you click on here, and you can say, okay, I want to use this application. So then I just hit turn on, and now it will open up again and saying, okay, I want to use one-tap sign, so sign in with Facebook. Now it's going to connect me up to Duolingo, and then I can say, okay, Glass, learn a language, and it will help me start learning a language. Duolingo, I have it on my tablet, and right now I'm learning Spanish. But you can learn Spanish, you can learn Italian, French, about half a dozen languages. Not a lot, but just a few. But anyway, this is how you install a glassware application on here. And if I take my Google Glass, so my one's a little bit different. My one has the frames on it. So some of you are wearing glasses, so I guess 3 of you are wearing glasses. And normally when you, this one does not work so well with glasses because it cannot sit at the same time as glasses. But if you wear glasses, then you can you can get your custom frames embedded in here as well. So this one is the same, but I just have my glasses on here as well. So if I plug this one to here, then you'll see. Actually, I'm not sure if I'm on the Wi-Fi. If I'm on the Wi-Fi, then let's see if I'm on the Wi-Fi here. I just have to adjust this a little bit. I'm not on the Wi-Fi. Let's see here. So this is what I can see on my display. I have a few more things. I have some stock markets. I went for a trip, so it has my trip information here, and then different messages. Okay. Let me see if I can connect to the Wi-Fi. So with Glass, of course, there's no way for me to type and to provide input. So you might ask the question, well, how do I connect to a Wi-Fi network? Because I can't provide input. So one way they do it is by if I go back to the actually here, I can go back to the My Glass website. Now I can go to the setup, and the setup here, I have to sign in again. Then you can you can go to My Glass, and it will allow you to set up a Wi-Fi network. So you click on here, and you can then enter the network name and password. Although I've forgotten the name for the network here. I think. Let me see here. I cannot connect to EduRoam. I have to connect to another special network we have in there. Okay, so but you can see here is the. You can see here is the. So if I go from the clock, you can go a little bit to the right, and you'll go to the settings. If I tap on here, it will go to a submenu. So you see some cards have the corner bent down on the top right-hand corner. This means that you can go to a submenu. So I tap on here, goes to submenu, and then it says the Wi-Fi is disconnected, but open network is available. So I hit join network, and it will give me some options here. And let's see here. I think I need Gun's help because I think I've forgotten the password. Yeah, let me just see. I can check my email. Here we go. Yeah, so this is the network name at LabNZ. So I put this one here. And then this is the password. And then what you have to do is you have to generate a code. So it takes those things, it generates a QR code. And now with Glass, I can go here, and I can tap on the I can hit join network, and then it will take over to the add Wi-Fi network. Now in this case, on the add it, it's going to turn the camera on, and you'll see the if I go down here, you'll see the camera turn on, and then I just need to look at the QR code, and it will from the QR code it will grab the information I just typed in there. So so now I just have to look down here, and now see it's connecting, and hopefully it will connect. We'll see what happens. So you said that before one of the things you're interested in is building a barcode scanner for Google Glass. So they already have a QR code scanner inside. You just have to look at the image and then grab from the QR code. So it's still trying to connect. Let's see. Having a hard time. Well, while it's doing that, I'll keep on talking, and then once it's connected, we can show you some other things as well. So that's the example of the Glass applications. And then now to build applications, there are two ways to do it, and in the course this week you'll learn both of them. So one is using the Google Mirror API. So the Mirror API is normally used for applications where you want to just push content onto the person's Glass display. So in this case, in my display you saw I had the CNN or New York Times. So in this case the content is generated from the CNN website, and they just push it out onto the Glass display. So very little interactivity from the user. Then there is other applications, so which require using sensors and using more user input on Glass. So in this case, use the GDK or the Glass developer kit to do that one. So let me give you an example with what you can see on my headset here. So here is the timeline again. So if I go along here a little bit, so here's the New York Times, for example, and the New York Times says it had 3 new updates. So if I tap on here, it will give me some updates. So here is 3 articles it has, and I can pick one of the articles and tap on it again, and it will read the article to me if I want to read it. Another example of that is CNN. So here's an article on CNN, and you can see this article about somebody beaten up in Israel. And if I tap on this one and hit play, then it will play the video. Actually, I think I might try and get from the network, so I may not play. Let's see what happens. My Glass is still not on the network. Oh yes, so it's an error because it cannot get the network. I'll get that fixed in a minute. So those are examples of Mirror API applications. If I want to though, if I go into this one, and there's other examples here. So one example is some games. So where's the games? A play game. So if I hit here, one of the games is one called Balance. In this game, what you have to do, clay shooter. In this game, what you have to do is you have to look with your head at targets. This is mimicking what happens when you shoot clay pigeons, I guess they call it, or clay targets with the shotgun. So they launch the target, and you have to look with your head and point your head at the target, and then you have to say bang. And then when you say bang, it will shoot the target. So let me show you that one. So in this case, it's using my head orientation, and it's also using the speech or the speech detection to detect that. So if I start it here, and you see the screen here, and then I can just tap, and this is said bang to fire. Now, bang! Oh, okay, too slow. Bang! See, it smashed it then. Pull. Bang. Bang. Oh, missed it. Pull. Bang. Pull. Bang. Oh, it's too far away. Oof. Bang. So you can see here, it's just using my head orientation to move around, and then using the audio input on here. But I'm not on the network I'm not on the network currently, so you can see it's all running locally on the device. So this is an example of a GDK application that's run all native on the hardware. So in the class this week, you'll learn how to build both of those applications, both the Mirror API and the GDK applications. I want to show you a couple more applications, and then I'll talk a little bit about some design principles, and then we'll break for some lunch. So one of the applications is one called Strava, and Strava is an application for cyclists. So as you're biking, you can measure the time you've been biking and also the distance you've traveled as well. So it allows you to keep your hands free while you're riding along, but record all the riding you're doing.
It will do all the calculations through GPS.
That's right, on the GPS. So you have to have your mobile phone with you as well, but yeah. And another application is called All the Cooks. All the Cooks is a cooking application. So it will let you, it shows you recipes, and it will show you all the material for the recipes and give you the steps for cooking instructions. So again, you can be cooking but seeing things in display while you cook, keep your hands free. There's an augmented reality application called WordLens, and WordLens is a translation application, and this lets you translate what you can see on glass to other languages. So I have this one installed, so let me show you this one working. So if I tap here again, it turns on. I tap here again now, and if I go along here, and it's called Translate. So when I start it up, what it does is it's going to, if I tap again, I need to go from English to French, say, or Italian, or let's see, well, let's go from English to French. So I tap this one, now it's translating English to French. Now what it's trying to do is I need to find some words. So they can recognize. So here's some here. So if I hold still here, you see this is the glass class, and you see how it replaces the word the glass class with the French. So let's try that again. So this is an application that runs on Android phones. So they have an Android version, but then they easily made a version for things. So all I've got to do is point my head at some words. So it says English to French. So if I point to here, so it'll find the words the glass class, and it replaces it. And so February becomes Ferreux, and Le Ver class is the glass class. So if I've got your Android phone there, so if you want to look, just look for WordLens, and you'll find it. So that's an example of translations application. And it's kind of augmented reality because what they do is they replace the text, and they make the words look aligned to the page as well.
Combine both platform application.
A Mirror API? No, separate applications. Yeah, because they the GDKs run natively on Glass. The Mirror API is just on the back end, so it's a little bit different. Yeah. So another example application is this virtual exercise companion from GlassFit Games. And the idea with this one is you can be running, and as you're running, maybe you want to have somebody running with you. So if I go for a run with Google Glass, I have the GPS, but then maybe I can look and I can see a virtual person running in front of me, and I'm trying to keep up with them. So on the interface here, you can see they have this red person is the running companion, and this is the map showing where I'm running. Here's the calories I burnt, here's the time, and here's the how fast I'm going, and here I am 5 meters behind. I have a video of this working, so I can show you the video, and you can see what the concept video looks like. Just go back to nope, it's not this one. Here we go. There's like two glass thing here. So you can be running and then you see the person running in front of you, or going down mountain biking, or maybe even skiing. Anywhere where you can use GPS and you can record your position, or riding through the city. And what you can do also, it says race yourself. So if I go for a run around the park here, I can record my path, and then the next day I can run again, and I can race against myself, or maybe even racing somebody famous. And it could be an athlete who's very famous. I can record them running around the path, and I can race against the athlete later as well. So that's another example. One of the applications we've been developing here at the HIT Lab is one called City View AR. So this already runs on Android phones in Christchurch. If you go downtown, there's been many buildings demolished as a result of the earthquake in Christchurch. So what you can do is you can take your mobile phone and you can look around, you can see buildings put back in place that used to be there. But we can make a version of this, we made a version of this that runs on glass as well. So you can walk around town and you can see the buildings that aren't there anymore being put in place. So let me show you an example of this working. So we're not downtown right now. So what it does is it checks the GPS position. If it can't find the position, then it will simulate where you are. So let me give you an example. It's working. So if I just tap through here, and I can go along here a little bit. So here's City View AR. So I start this one up. Then it takes a little while, but it will load up some content. This is GPS not available, but if I look around, you can see there's a radar display. If I look over this way, you'll see buildings start to come into place, and look up. This is the DTZ building, which used to be in Christchurch. I can look down this way, down the street, and this is actually a panorama. I can tap on here, and it will load up the panorama. The panorama is a photograph taken a week after the earthquake, so I can look around here. I'm looking around the image in the panorama, and it's kind of a 360 photosphere as well. So this allows you, and if I was walking down the street in Christchurch, then these buildings will be put back in place with empty parking lots right now, using the GPS from the phone as well. Okay. So that gives you another example of a kind of more augmented reality application on glass, where you're using the head tracking and doing 3D graphics rendering. There's also some medical use cases. So people have been using for a remote education or remote assistance. One of the applications you can use with glass is taking the camera video and streaming it remotely. So people have been using it for doing a surgery and streaming the surgery to a classroom remote, so they can provide some a remote education. Or remote assistance. So you could stream the video to an expert who can help you. So one example of that is the Viper telemedicine application. So in this case, you take the camera view, you stream to a remote person. The remote person, the expert here, can then put their hands in front of the camera view and send it back, and then you see these hands appearing on the display. So it's like the remote person can put their hands into the operating theatre. So let me show you this on video.
They are looking over some images prior to Ponce performing a shoulder surgery in Birmingham. That extra hand belongs to the Atlanta doctor, Connie Dentaluri. It's telemedicine with a twist.
It's real time, real life right there, as opposed to a normal Skype or normal video conference call, which is just back and forth dialogue, but it's not really interactive.
And it's
So he's got his Google Glass on in the operating theatre.
A virtual reality technology developed at UAB called Viper, along with Google Glass. The camera in the Google Glass sends an image of the surgical field to Dentaluri's computer in Atlanta. He sees what Ponce sees, and Viper allows him to reach into the virtual field in real time. In turn, Ponce sees Dentaluri's hands and instruments in his Google Glass heads-up display.
A surgeon, a remote surgeon, is able to put his hands or her hands into the surgical field and provide assistance to point out different structures, the anatomy, the placement of retractors. So it's a safety net to improve patient care by having that assistance from an expert who's not in the room.
Ponce and Dentaluri teamed up for this first ever Viper Google Glass operation. It's a good way to teach surgical residents or allow a veteran surgeon like Ponce to serve as a mentor.
Have residents graduate or an attending who's on staff somewhere else is learning a new procedure and would want help or assistance for the first 2, 3, 4, 5, 10. This system is able to provide the help, but then also they acquire the skills and the education while they're doing the procedure.
It's exporting expertise.
UAB neurosurgeon Bart.
So you can see in this case they are using it's a kind of an update version of what I showed you before with the British Telecom system, where they can see what the remote person's doing, but now what they can do is they can put the person's hands in their space as well. So let's give you some ideas of applications, and during the week you'll be able to try many other applications as well. So let me talk a little bit about some designing guidelines for designing applications, and then we'll have a break for lunch. And after lunch I'm going to start talking about some tools you can use for prototyping and for testing applications. So first of all, one underlying principle is that glass is kind of like a now machine. So it's basically it's about focusing on location, context, and timely information that's right now. So if you have the cloud, with cloud computing, the idea is that you store information forever. So when you put something onto your Gmail account or use Amazon Web Services or something, it gets stored forever. If you've got a laptop computer, maybe the information on your laptop is around for a year or two until you get a new laptop. With a mobile phone, maybe for a week or so. With glass, the idea is you capture information during the daytime or during 1 or 2 days, but then you will sync it up with the cloud or with your laptop, and so it doesn't get stored on the glass for very long. So it's very much about trying to enhance people's interaction in the here and now. So there are some lessons that have been learned by the Glass team in the development of Google Glass. So one of them is that building transparent applications can be difficult. So you're trying to create the illusion that you can see through this display, and the information you show on here can be modified depending upon the background. For example, here's an image of a picture of an island. When you see it in the dark room, you can see it looking like this. When you see it outside, you see it looking washed out like this one as well. So the same content doesn't look very good depending on the context you're showing. With glass also, reading at length is very uncomfortable. You don't want to read long documents. It's much worse than using laptops or cell phones. So you want to be able to limit interactions that require reading. Looking and being immersed inside the glass display can be uncomfortable as well. So you don't want to necessarily have build applications take a long time or require lots of people's attention. Providing detailed input and precise interaction is very difficult as well. So you can say the person is trying to speak some input. He said Moab is like 100 degrees right now, but we're having such fun. I think they're saying so much fun, but the speech recognition is failing. So you have errors with the voice that comes in as well. So you want to make sure the interaction is quite short. So there's some design principles that are followed. The first is that the world is what you're trying to help people experience. So the idea is to get the interface out of the way and let people experience things in the real world. So you want to try and enhance interactions in the real world, so being able to share scenes, or in this case, having a first-person interface. And having first-person interface is much more personal than other types of interaction. One of the best things to keep in the back of your mind when you're designing for Google Glass is that it's kind of like a rear view mirror in a car. You know, when you're driving a car, you've got the rear view mirror, and you'll look up occasionally to see information or what's behind you, but you won't try and drive all the time by looking at the rear view mirror. So you want to be able to keep the information density very low, optimized for speed and minimum distractions. It's also a very personal device, so you want to be able to make the interface very personal as well. So the device should adapt to what your user context or what you're doing. So for example, if you're biking along, then the glass should be able to recognize that you're biking and provide information relevant to that. You want to use glass to try and communicate with the people that are closest to you. You've got lots of other devices to communicate with the whole world, like mobile phones or your laptop computer, but this is just for people around you or your intimate close friends. And one of the most important design interactions is this idea of micro-interaction. So if you have a mobile phone and you want to take a picture with a mobile phone, you have to pull it out of your pocket and take the photograph. It may take 30 seconds or a minute or so to take the picture with the phone. With Google Glass, you just have to put up and push the button here. It takes just 1 second to take a picture. So the idea is that you can, with Glass, have the interaction time is much shorter. So that means that the attention time that you give Glass should be much shorter as well. So when you're using a mobile phone, people typically split their attention between the display and the real world. For example, here's a study that was done by Antti Olsvater a few years ago, looking at the amount of time people would spend on looking at a display. So they asked people to read text from a mobile phone screen in different contexts. So first of all, in the laboratory, so they took them into a lab for a user study, and they said that when they were reading text on the lab, people averaged about 12 seconds looking at the screen before they looked away. But then when they went down to other contexts, so if they're in a car, it was, if they were riding in a car, so riding on the subway, it was around 8 seconds. When they're walking down the street, they typically would look at the screen just for 4 seconds before looking around at the surroundings. And conversely, this is the number of times you switch between the screen to the real world. So in reading one page of text, the person on the busy street would switch about 8 or 9 times between the screen to the real world. So you have to think when you're designing for a mobile device, designing for these micro interactions. With a mobile phone, when you're walking in the real world, it might be 4 seconds looking at the screen before looking away. With Google Glass, you can just look up and you can look down again, and it's just 1 second. So you want to design for interactions that take less than just a few seconds. So that means you want to build basically one task per interaction, one input per interaction. So that's why with Glass, when you have the screens, normally there's only one piece of information on each screen. So I can look up or I can turn the display on, get one piece of information, and then turn the display off again. You also have to think about designing for cognitive load. So with computer interfaces, you can kind of have a continuum depending on how much input the interfaces require. So, for example, with direct manipulation, if I'm using my mouse on my keyboard, then this requires quite a lot of cognitive load, and I have to look at the screen as well, so I've got to have both perceptual and cognitive ability engaged at the same time. So that's quite a high load input. Conversely, I could have a system have sensors that automatically respond, so like a smart room or something. In this case, it requires very little input from me, so it requires very low cognitive load. So with Google Glass, when you're designing interfaces, you want to design them that require the least amount of cognitive load initially, and then maybe ramping up more as the person engages more. So for example, when I'm wearing glass, the system may not know what I'm doing in the real world. So, you know, it doesn't know whether I'm riding my bike or whether I'm sitting on a down or walking or whatever else. So when it starts trying to interrupt me to provide some information, it has to provide the least amount of interruption possible and least amount of cognitive load. So right now, when the screen is off, if I get a email message, the first thing that happens is that I hear a bing in the audio in the headphones, but the display doesn't show anything, just using Bing. Then if I look up or if I tap the display, it will then turn on the display and show a message. And then if I tap or if I say reply, then it lets me start replying. So as I'm going from left to right, it's going from a small amount of engagement to moderate engagement to total engagement. So if I'm very busy and if I hear the bing in my ear, I don't have to look up or I don't have to tap, and it will just go away. And I can look at the message when I want to. So the idea is you want to gradually increase engagement and attention, and you want to respond to user input. You can also use other metaphors to help with that. So one of the interesting examples done a few years ago was a project called the Nomadic Radio, where they built an interface that had no display, the visual display, but uses audio input. So they took just some speakers you mounted on your shoulders, and they built a spatial audio metaphor. So they had this surround metaphor, and you would hear audio notifications appearing around you depending on what time you got them. And it also had this ramped notification idea. So when you got a voicemail, you'd hear a splash in this kind of river, and then if you tapped or wanted more information, then it would give you a bit more information and then a bit more information about the full body of the text. So there's kind of layered audio notifications. So when you're designing glass applications, you've got to think about the same way as how you can build an application that provides minimal interruption and then just gives more information as the person disturbs you more. So a few more design guidelines. First of all, you should design for glass. So you can see here this is Instagram, and this is Instagram on the phone or on the tablet. But when you move on to Google Glass, they change the form factor to make sure they show just one piece of information, and it's very, very simple. So you can't just take a standard Android application and reproduce it onto Glass. You've got to make it, design it for the user interface. You want to get out of the way, so you want to try and enhance, not replace real-world interactions. So here's a person gone to the aquarium, and it's showing information in the aquarium about the jellyfish that they're seeing. You want to make sure it's also relevant. So here's somebody going shopping, and then when they go shopping, they see a shopping list. Avoiding the unexpected. So now it's 3:30 in the morning, and suddenly an advertising message appears on your Google Glass saying that your cabbages are on sale for special. This is not what you want to get at 3:30 in the morning, because you're either sleeping or you're going out with friends. You don't want to see advertising about cabbages. You also want to build for using voice interaction or very natural gestures, and having kind of fire and forget interaction model. So you tap and you interact and you go away. So some other best practices. First of all, don't design an app. So the Glass operating system is based on a time-based model, so timeline, not a single app. You have to know what makes Glass different than a phone. So for example, you have voice interaction with Google Glass, which you don't have with phones sometimes. We've already talked about this one, about how you can't just port your mobile application onto Glass. You have to try and make the application custom for Glass. And then design for the iPad now. So looking at what people are doing right now and designing for that. And do just one thing at a time. So here's the person's taking a picture, so the next thing they can do is share. So all they can do in that card is just share the picture. Designing for emotion. So here's Facebook application where you can click to like the situation. Making it glanceable. So in this case, you know, with the micro interactions, you're just going to look at the screen and you want a quick piece of information. So these two screens are showing the same information. These are from a running application, and I want to show you how many steps that you have taken. But you can see the one on the left has more pieces of information. It has how many steps you've got, it's got how many steps you've got to go, the percentage you've got going, it's got the picture there. The one on the right just has two pieces of information. One is the number of steps, and the second is the timeline showing how much you've done, how much you've got to go. So same as what you got there. So you can see if you are in this one on the left, there are 6 pieces of information. One on the right, I guess 3 pieces of information. So if you wanted to add up the amount of time it would take you to understand all the information, you can measure the eye motion, and it might take almost 2 seconds to see all 6 pieces of information. But on the one on the right, it's less than 1 second. And then you have to think when you're running, you're also probably moving your display around. So you know, you want to test to see how glanceable it is. So if I'm running my glasses shaking around, I can't actually see all those 6 pieces of information. But even if it's shaking on the one on the left here, I can see very quickly what I'm have to do. It's also important to test your design indoors and outdoors. So here's indoors, you have to make sure you can see, okay, here's outdoors, so you can make sure you can see the background clearly. Because with glass, when you show something on black, it becomes transparent. So white is like your new black. So instead of thinking about mobile devices where you've got a black screen you're showing content on, you want to have a white background because you can see white very easily and put black on top of it. And also, with glass, black is not really black, because when you look on black here, it looks a little bit, you have to light the screen a little bit, so it looks more like a dark purple or some dark color, but not completely black. We also have to establish a hierarchy by using a color, not font size. You don't have a lot of space for changing font size, so you can change the color. So you have the white is like a bold, and then the grey is like regular size. If you've got some special typography for a brand, then you should use it. You can also use relative information displays. So when you've got a map, it shows your location on the map and information relative to you and that location. And you have to remember also, people have other devices that they typically carry. So you can have your glass working with other devices. So if you've got a phone, then the glass will work with a phone, or maybe a wristband or something like that as well. And the glass screen is just one part of the user experience. So if I'm using Facebook on glass, then I want to use Facebook on my mobile device as well and send it through. So that's all I want to talk about for now. I think what we'll do now is, first of all, do any of you have any questions about what I've been talking about? And otherwise we'll break for some lunch, and then we'll come back after lunch and I'll actually start showing you how to build some things as well.
Does the glass have the cameras?
Camera?
Cameras.
A compass?
Yeah.
Yes, there's a compass, yes. You saw that when I was doing the game, with the, when I was lifting my head around, that was using the compass to detect where I was looking. Yeah, so it has an IMU sensor, but it also has a real compass as well. I can show you. So if I go here and turn it on, then I click on here and I can go to, let's see here. This one, let me see. Okay, so it says show compass. I tap this one. This is now having a first-person compass. So I guess this is the east direction over here. This is north this way, and west is over this way. So it's a real compass on here as well. But using an IMU sensor. That's right, yeah. Does anybody have any other questions? Yeah.
I heard that you can't actually have the password of the glass running for 1.5 hours.
That's true. So there are a couple of things. So first of all, the battery is quite small. So if you, for example, want to run the display and the camera full time, then the battery actually would go flat in 45 minutes. There's not a big enough battery to run it for an hour. But most people use glass just to, using the micro interactions I was telling you before. So if I'm wearing it all the time, maybe 10 times an hour I might look at it. So get a notification, tap it. And if I do that one, then you can, the device will run for 6 or 8 hours without running out of battery. Also, because the battery is very small, it can recharge very quickly. So you just have to plug to the USB port and it will charge very, very quickly. Maybe in 15 or 20 minutes. Yeah, but it does get hot though. So if you're using something where you're using a CPU quite intensive, like a computer vision processing, and you're using other sensors as well, like the IMU at the same time, and the camera for input, running everything at the same time, then this will start getting quite warm on the display. Yeah.
In terms of the multi-frame, so the glass is actually multi-frame. If I want a comfortable at the same time, and it or not.
I think so. You'd have to ask Gun because it's just a normal Android system. So if the Android OS supports multi-threading, then it will support multi-threading. Yeah, but Gun will be able to tell you about that one. I'm not sure. He's done a lot more programming on glass than I have. So yeah. You had a question as well, didn't you? As I know.
Apart from the default instruction glass,
Yeah.
can we add more instruction to the glass?
You mean for speech input?
Yeah.
Yes, you can. And Gun will talk about that in the next day or so. So you can add your own voice commands as well. So if I build an application, then so here's the menu. So if I go OK Glass, then now it has a list of items here. If I look up and down, turned off. OK Glass. You can see there's a whole bunch of things here. So I can say moon glass. Moon glass. So this is an application we built ourselves. It's not going to work, but we added those words moon glass to the menu. So you can add your own. And this is not going to work, so we don't have to tap it there. But you can add your own menu commands to the start menu, and in an application you can use speech input as well. So you saw that a little bit with the game when I was going bang bang. You can add speech input in the menu as well.
So you have been working with the glass for years. What do you think the main drawback? Is there any main drawbacks or?
Yes, there's a lot of disadvantages. One is there are some technical limitations. So this is about the same power as a mobile phone from about 18 months ago. So it's a little bit slow compared to modern mobile phone. But still, it's still quite powerful. So there are some limitations around the technology itself, but there's also some social limitations. If you wear this out to a party or somewhere outside or amongst friends or a restaurant or something, then people might treat you differently. So I think, but for some applications it doesn't matter. If you're building it, like in the case for Derek, if he builds an application for couriers, maybe it's okay because it becomes part of the courier uniform. But if you're going to go to a social situation or walking in public and people are laughing at you because you're wearing Google Glass, then that doesn't help meet your social needs. So I think there's a lot of potential applications in the business sector or niche sector, like I showed you the medical applications, where people are already wearing displays or other devices that they can adopt the technology immediately. But then there are other cases where people may be reluctant to wear it because of social factors as well. So there's some technical limitations with glass, and there's also some social limitations as well. Yeah. Any other questions?
In terms of the storage,
Yeah.
how big is storage?
16 gigabytes, but only 12 gigabyte is available. 4 gigas for the OS, and there's 1 gigabyte of RAM. Actually, the new versions have 2 gigabyte of RAM. But then, as I said before, what they try and do is that you store some pictures or video. But when you get back to the Wi-Fi or you plug on to your laptop, it will automatically sync with your laptop. So it will copy everything onto your laptop. So it will go away after a while.
So the glass 20 lectures.
There's a limited amount you can do with that one. I can show you, because the computer vision, actually there's a website called On The Go. Let me see here. Let me just say if I, this one here, maybe. Okay, so there's this company called On The Go, and they support use of hand gestures with Google Glass. I think there's a video, here we go. Yeah, so you can play the video and you'll see it performs simple recognition, so of static of hand shapes. So when he makes a fist, it's going to take a picture and then he can swipe with his hands and it will swipe through the pictures.
It's kind of 6 sense.
Yes, not as
Not exactly.
not as much processing power, but similar to 6 Sense, yeah. So it's detecting simple swiping. So as you swipe, it will go through different cards, and then you can see the hand tracking is working here. And then you can do some simple gestures like thumb up gesture or frame gesture for taking picture. So what the advantage of this is that you can wear gloves and you can interact with glass. Currently with Google Glass, because it's capacitive sensing, you cannot wear gloves unless you have a special type of glove. So he's going to make a frame gesture, and he'll take a picture of the animal he's seeing there. And you can now he's playing a game. Yeah, so some people have done some simple work, but and we're doing some research here in the lab, and we'll show it later in the week where we're doing 3D hand gesture interaction with glass. But the processor is too slow to do very much complicated interaction. Just a few simple recognition. Okay, does anybody have any other questions? Okay, let's stop then, and then what I will do is we'll take a break. I will show you where to get some lunch, and we'll have an hour break for lunch. During that time, I need to get some stuff set up for the second part, and then when we come back, we'll start talking about how prototype applications. So we'll come back at 1:30. So.
Don't worry about me.
Oh, okay. Do you want to get some food on campus or?
No, I don't know.
Okay, of course you do. Yeah. So, just wait for a second. I just have to tell Gunn I'm leaving because he'll have to stop the recording. So, please come with me, and we'll. If you have some money? You still have money? Yes. Great, perfect.